I was smelling a burnt resistor or burnt component smell today, and I thought maybe it was the LED light, the DIY LED lightings I have in the garage, and I turned everything off thinking it would go away, and it just kept going, getting worse and worse, and my wife started complaining about it, so I came back out, and sure enough, it was getting worse. Turned out it's my trusty receiver test set, the spectrum analyzer and tracking generator, that big thing, the HP9821. And so so I've had to open it up and pull out the power supply, which is modular, which is nice. And this is the thing that smells. And I should have videotaped the taking apart, but let me show you. Let me show you what I've got. First of all, we'll show you the power supply that came out. It is on a nice frame, and it has all of the inputs. So the power connectors on the back, and there's actually a DC connector that I pushed a little bit here. You can actually run this thing off of a battery, believe it or not. The power switch is a long stick that goes inside, and that stick pushes way inside here, way to the back, and pushes this switch right here. So this thing is self-contained AC wise, and the output is marked here on the board: battery plus, battery minus, plus 40, minus 12, plus 12, plus 5, and another plus 12 over here. So I suppose even if I can't fix this, I could maybe put some individual ones in. Now, I do have an ace up my sleeve. I do have a complete separate unit. I actually bought two of these at the same time, keeping the other one for spare parts. So so I should be able to, if I can't fix this, or I could put two side by side and maybe fix this one, or I'll just put the other one in. So that's the power supply. Let me move that out of the way so we can take a look at the rest of it. You might be interested in what's inside this thing. So on the back here, there's a big RF section that's missing here. Let me go get that. So this came out of there. There's an SMA connector and two other ones, so it's an input thing. There's a ribbon cable that talks to this thing. So this is a bunch of amplifiers and attenuators and all kinds of things like that. So all kinds of RF goodness inside here, but it comes out as a module, so took that out. I actually had to remove that to get to the switch. That long stick goes along here, and you have to take this off to get to the switch. So there's obviously some more RF stuff over here. Let's spin this thing around. Goodness, you've seen the front before. So in the back, there's a section here. There's a cover that I took off. A section here with a bunch of cards in it, and then there's a section over here that I've opened up and taken out too. And you can see that this is like a motherboard almost, where you can put a bunch of cards in. And there's actually individual cards for the spectrum analyzer, for the RF generator, for the AF measurement, RF measurement, an output card. So they're all modular, and they go in there. Let me take the camera over and I'll show you those cards. So here they are. They have these nice little ejector things on them. So RF output, signal generator, synthesizer, optional reference. So I think this is a high grade 10 megahertz reference. A receiver synthesizer, and then the spectrum analyzer. So you could buy this thing in all different sorts of configurations. Spectrum analyzer is the best plug-in that you can get for this thing. So if you do buy an 8920 or an 8921, make sure it's got the spectrum analyzer plug-in into it. The optional reference is nice, but not needed. But yeah, those are, they just have a connector. There's two connectors here and a sub D in the middle. They just plug in. They're really, really cool. So this thing was made to service, definitely. Of course, you couldn't service to the component level, but you could just buy one of these modules, plug it in, and be done. So let's see if we can see anything here. Certainly we have the input here, some very large caps here. These are Rubicons, of course, Hewlett-Packard. A lot of Elastic. Smelled like a burning resistor at first, and then it started to smell like something that my wife described as a dead animal smell. So probably a capacitor went. Oh dear. Let me let's see if I can move the camera here, and I don't know if you can see what I'm seeing. Probably not. But this, let's see here. Let me get something to point with. So there's a bunch of capacitors here. You always look for bulging tops, and this one definitely has a bulging top. And down here, you probably can't see it, but that should be about the same level as this, and it's poofed up. It's like that can just kind of ejected up, and it's definitely opened up the bottom of the capacitor down here. So definitely that's needs to be fixed. Wow, there's a jet going overhead. It's really loud. That's very unusual. Sound like a military jet. We live close to an airport, but they're definitely not this low. Okay. Yeah, I think the thing to do is to get all of these replaced. I don't know if there's anything more than just a bad capacitor, or not. But definitely that needs to come out. So I pulled all the capacitors out. I don't know if you can really see that in there. There is an ugly burn spot right in here. Definitely has some traces gone, so we'll have to wire it from the backside. Nothing else seems to have been leaking though, which is good. This is the pile of capacitors here. These are real nice ones here. They're all Rubicon, 35 volt 1000s. Those are cool. And then a bunch of these, which are 50 volt to 470, and then some biggies, a 400 volt 220, and a big caution sign, which is a 400 volt 100 microfarad. You can just see it there. So got to get those on. A bunch of little ones too, 47 microfarads and 33s and stuff. But not too bad. Make a trip to DigiKey. I'm not going to skimp on surplus capacitors or unbrand named. They're going to be nice ones to go back inside this thing, and hopefully it fixes it. Alright, so this PC board wasn't the highest quality back in the day. This is made in Hong Kong, so anyway, the vias, or the plating, the through-hole plating wasn't very good on this board. So I did pull up some pads, and I do have some stuff that just got eroded away. So I went ahead and I looked at the circuit on the top and the circuit on the bottom, made sure everything was going to connect. And there were some things that weren't going to connect because of lifted pads and stuff. So I took a silver silver Sharpie, and put in some lines here. So when I put these capacitors in, they're just going to be wiggling in the breeze, and I'm going to put in wires and jumper them where I have the Sharpie mark. So there's a kind of a star jump here. Make sure all these grounds are connected. There's a short little jump here. That was where that capacitor that burned up just destroyed the board underneath, so I'll need to put a short little jumper here. And there was one other one, a couple other ones. One here, this one I just want to make, I think it might work, but I wanted to make sure because it's this big giant capacitor, and the other giant capacitor here. So I want to make sure those are both beefy. So I'll put an extra jumper here, an extra jumper here. That was those big giant capacitors. So I'm expecting the capacitors when they come in to be smaller than the originals. Seems like every time I buy capacitors, they get smaller and smaller and smaller. So I'm anticipating these. Threw it on the ground. These capacitors probably being about 1/3 this size when I end up getting them, whereas these are pretty big. But anyway, it'll work. No crucial aspects of this board. It's just a power supply, so that should work pretty good. There was a little piggyback board that went on these connectors here. There's this board here that plugs down, and it's got the feedback chip on it, and it did have a electrolytic on it as well, so I'll go ahead and replace that while I'm at it. That'll pop back in. Taking this board out will make it easier to put the heat sinks back on. These chips here mount against the L bracket of the big PC board aluminum frame, and there's some spring clips that hold it on. They're insulated, I think, from the aluminum as well, so there's like mica strips underneath those. I don't see anything else wrong with the board, so I'm hoping it'll be okay. I did make a mistake. Since I do have an extra one of these in another unit, I could go ahead and swap the power supplies, but then it's probably ready to destroy itself too. I should have bought a double set of capacitors and replaced the capacitors on that known working board, make sure it still works, and then it'll have fresh capacitors on it, and then do this board, and then if something is wrong with this board, I can compare the two. So I still may do that. I think I'm just going to try to make this board work right from the get-go. Since it's already on order from DigiKey, I'll probably get those parts in a day or two. So it was about $17 worth of capacitors and $3 shipping, so $20 to fix it, hopefully. So I thought I'd test a couple of these capacitors just for fun. I have the 50 volt 47 microfarad on there right now, and it's measuring 42 microfarads and 0.3 ohms, so that seems very reasonable. Let's try a different one here. Same thing. Looks good. All right, let's try one of these. This is a 35. There was quite a few of these. I think there's nine of these on the board. Oops, sorry. These are a 35 volt 1000 microfarad. Well, let's hook it up. And the ESR on this one is 0.03, so it was good. Let's try this one here. .03 as well. Let's try one of these guys. These are 50 volt 470 microfarad. Oops. Well, 0.05. So far, they're all looking pretty good. Yep, 0.03. Huh. Well, with that one, we just decided to give up the ghost. Let's see here. Yeah, these are all testing okay. Let's test this baby here. Can't make contact to it. Well, this one's not testing at all. Oh dear. Maybe it's dry. Oh, there we go. 0.4 ohms. That seems a little high. It is a 400 volt capacitor. That's the big one here. And the other one, oops. 1.5. I don't know. They all seem pretty good. They are Rubicons. So that one may have just been ready to die. Probably all these other ones are ready to die too. I'm not sure what this thing was built. Probably in the late 80s, I would guess. Let's see, is there a date code on the on this IC here? Oh, 1993. So early 90s. So I'm still waiting for DigiKey to deliver my capacitors. And I thought I'd just take a quick look around the board to see if anything else looks sketchy or not. At first glance it didn't. But I did see a lot of these really wild power diodes. There's one here that's on this, zoom in a bit. There's one here that's on this wild heat sink. There's another one here that's on a wild heat sink. Those are really weird diodes. And I thought this was an FET or a transistor or something, but it only has 2 legs on it. And it's on this big giant heatsink. But it only has 2 legs, so it's definitely a diode as well. And it definitely feeds this bank of capacitors here that is kind of associated with this one that went bad. So anyway, I thought, well, let me just go around the board with my diode checker and just make sure everything's okay. And so... zoom out here. So, you know, there's like this one here. Yeah, 0.38, so it looks like a Schottky. There's a real big one down here you can't see. 0.35. Here's one here. 0.4, fine. And then there's this funny one in the back here, so let me do it this way. And it says 0.07, so let me flip it around the other way. And it says 0.07. So I don't think that's very healthy. So let me remove it from the board so we can test it better. Alright, I've used my solder sucker there and tried to remove solder out of this hole. I think I got most of it here. It's still kind of stuck in there. Oh, there we go. Got one side broken off. Oh, there it goes. Alright. So, it's out here, and it says 4 amps. Okay, let's test it out of circuit. And 0.17 in that direction, and nothing in that direction. So maybe it's okay. I have I looked at my junk bin. I do have some 100 amp ones here. don't know if I want to replace it or not, if it's good. They measure 0.2 volts and nothing, so this is a 4 amp diode. This is a 100 amp diode. Do I want to replace it or not? Oh, that's a hard one. Are they the same direction? This one is that direction, and this one is the same direction. So they are pin compatible. Oh my goodness, what do I do? I'm tempted to put the 100 amp version in there just in case, but this one's still good. I guess I'll start with this one. Put it back in circuit. Let me go back and see what's going on here. So here's where it was soldered in. Uh, 0.07 volts and 0.07 volts, and if I, wow, that is odd. That is odd. It means that there's something in there. Maybe it's just this resistor. Maybe this resistor is such a low value that it appears. Let me measure the resistance here. Oh, there we go. 46 ohms. 46 ohms, and this thing looks like a 40. Well, it's yellow. Looks like yellow, brown, black. So I'd say 41 ohms. But it's measuring 46 ohms. So it just must be a bleed. Must be a bleed resistor for things. So I think that part of the circuit was working well. So I'm still going to say it was just the just that one capacitor that was for now. So I'll put this one back in circuit, and I'll put some new heatsink grease on it and make sure it works better. And leave my 100 amp in the drawer because I need it for something else. All right, there we go. Nice liberal application of heat sink grease. And I was saying that was 100 amp. I meant 100 volt. It's a 100 volt 10 amp, which is the replacement that I had. And so it's not a 4 amp, 10 amp. Okay, I probably could have put the other one in there, but let's go ahead and just leave well enough alone, right? If it ain't broke, don't fix it. So, yep. Should be. I think the DigiKey stuff will come tomorrow or the next day. They're usually pretty quick about it. See, how many days has it been? Yeah, it might even be today. The mailman hasn't come yet, so that'll be great.